So I'm Zander, and I'm excited to be here today. Maybe introduce some of you to real-time data and streaming data, or maybe broaden some of your knowledge on the topic. So today, real-time data is all around us. Interacting on social media, whether it be messages or interactions, or the financial markets, or in manufacturing, where autonomous robots do a lot of the manufacturing today, creating data in real time, or even our vehicles, where knowingly or unknowingly, they collect some 25 gigabytes of data per hour, which is really quite scary and also shocking. Or in our devices we carry that are knowingly or unknowingly tracking us in our day-to-day lives. So the data is all around us, and companies today, leading companies today, are kind of leveraging streaming data as an advantage. And so I think it's really relevant for practitioners and developers and technologists in PyData Global talks to kind of learn about how we can stay relevant and excel by knowing how to work with real-time data. So before we go any further, a little further introduction to myself. So my name is Zander. I'm working on Bytewax. Bytewax is a stateful stream processor. It's open source and it's Python native. And we'll talk more about that later as a solution to real-time data. Outside of work, I'm a proud human and dog dad. That's my daughter, Zaya. If you're thinking about doing a startup or having a child, don't do both at the same time. It makes things a little harder. Outside of work, I like to get outside. This is in New Hampshire on Tuckerman's Ravine, which we lucked out on a windless day. If you haven't been there, it's one of the windiest places in the world. So we got really lucky. When I'm not in the Bytewax Slack channel, you can also find me in Santa Cruz in person. If you're here, send me a LinkedIn message and happy to grab a coffee. Okay, so that's me. We got that out of the way. So what are we doing today? We're going to talk about real-time data. We're going to talk about what streaming data is. Then we're going to give you an introduction to Bytewax as a solution to working with streaming data. And then we'll do a little working example with code that you can follow along and I'll share afterward. So first off, very high level, maybe a little bit fuzzy, but what is the definition of real time? So real time could be defined as anything that a human perceives to have happened in real time, which is like kind of a crappy definition. So what it translates into is things that are in the sub-second realm. And depending on your application of whatever you're doing, it could mean closer to zero or closer to like happening instantaneously or not. What does that mean in the scope of data? So real time, in the world of data, real time means that the data is available for use as soon as it is generated, that the data is processed immediately, and that the data is made available to the consumer or whoever is the end user or end consumer of that data post-processing immediately as well. So all of this process needs to happen in a real-time and low latency manner. So that's great. We know what real-time data is. So what is streaming data? So streaming data is actually the technology or capability to enable real-time, but we'll get into that a little bit more. What I like to do when describing what streaming data is kind of use it as a comparison with batch. So the first thing we can look at is the data itself. So a stream of data is a continuously generated and unbounded set of data. Unbounded is kind of the key word there. We don't know what the end of the data looks like. In some cases, you don't even know when it's going to arrive. A batch of data, in contrast, is a defined bounded set of data. And due to the nature of the differences in the data, we use different processing techniques and paradigms. And that led to stream processing and batch processing paradigms. Stream processing is effectively processing each data as it arrives, sort of one at a time, is like a loose definition we can use. Whereas batch processing is where you have that entire set of data and you're doing the processing over the whole batch. one of the nuances here is that both of these techniques could in fact provide a solution that is real time depending on your application. If you squish your batches smaller and smaller and smaller, you could get to a solution that happens in what is perceived to be real time, but it's not always the latency that you require. And there's some other nuances there. But at this point, you might be wondering, okay, if micro batching can solve the problem, why do I even need stream processing? So we're going to take a little like sidetrack here. Oh, we're going to reconnect this thing. I like to use generators, Python generators, as a little tool for kind of describing streaming data. It works for me. It's not a perfect way to do it, but it's a nice little example. So in Python, we have this idea of generators where it's an iterable type of object, and every time you request the next thing, it will provide you with what's available. And so we can kind of showcase this by making a little generator here called myStream, and it's basically going to yield out a random integer between 0 and 10, and we'll have this sort of fake stream of data. And you can imagine this could be a stream of sensor data, and it's just sort of like the temperature or something like that, if you want a more concrete way to tie that down. Okay, so in streaming data, you have this idea of the actual stream of data. So in our case, that's the generator. That might be a set of sensors, IoT sensors, telemetry data, whatever, generating these values, and then it's available as a stream. And so those are called the producers. And then you have on the other side the consumers, and those are those that are consuming the data downstream. We can kind of stub this as a handle on our generator. And so in practice, when we think about streaming data, we think of the data as being pushed towards the consumer, but in reality, it ends up mostly being that the consumer is asking downstream, is asking what's available from the system that's sort of holding what was produced by the producer. And so we can simulate this by saying, okay, what's next in the stream and next in the stream. In this case, it's kind of generating that. So it's faked, but you could understand that it's asking basically the consumer saying, hey, what's next? What's next? Give me the next data. Give me the next data. Now, the next step would be to process that data. For whatever reason, this is like a generally applicable thing. The same way you process batches of data, there can be so many reasons why you would process the stream of data. And it can be very straightforward. You may just want to take that stream of data and maybe enrich it or filter out something. Maybe you want to mask an email, or maybe you just want to divide the number by 2, which is what we've simulated here. So we can take our generator, which is our stream, and we're just going to kind of iterate over it and modify the items one at a time. That can only get you so far. So at some point in your journey of using streaming data, you're going to run into the idea that you want to have an idea, you want to have a context of what has already happened before you get that next datum. And so that might be that you're looking to have a window over time, and you can say, hey, I actually want the average of average of the values over a window of time, or maybe you just want to collect a certain number of items and then reduce them. So you get these sort of slightly more difficult things to do. And we've wrote a little way to showcase a very, very simple example where we're just basically maintaining 2 values and then getting the mean of those values. And there you can see that. So we're kind of playing around with like a stream of data and the different things you can do with it. And you might, at this point in time, be thinking to yourself, okay, that's super easy. Why do I even need a stream processor? Why can't I just, do what we were doing right there and kind of loop over these generators? And it gets complicated rather quickly. So what would happen if we had many different sensors providing those values. And so we had many different keys. And whenever we did our computations, we actually had to make sure that the right data was added up or right data was accumulated for the right key. And then what if we needed to do a time-based window? So what if our values were provided with event time, or they weren't provided with event time, and we had to figure out system time or how to parse that event time and how to create a time-based window and all the edge cases associated with that. What do you do if it's a rolling window or a tumbling window or all the different types of windows? Or you might say to yourself, hey, I actually have multiple streams of data. How do I put them all together in the right way? And how do I reason about that? And then maybe you have a situation where you have a machine that crashed or your system crashed, and you need to figure out where you were in the stream so that you can start processing again. And what happened to all those averages that you were, or the accumulating values that you had going on for those different keys. And then finally, where it gets complicated and we get into the realm of distributed processing is, what do you need to do when things need to scale up? How do we make sure that the right data goes to the right node or process so our calculations are correct? So it's not the processing of one item at a time that makes streaming data hard. It's when we put all of those things together. And so that's why stream processors exist, and that's why Bytewax exists. Bytewax exists to provide a Pythonic way to process streams of data without having to worry about the complexity and the details that you probably started to imagine when I was listing them out there. So stream processors give us easy to use semantics to connect to streaming data sources and then process that data as windows or with joins, or to filter and enrich it, and then also on how to scale our ability to have to process more data, so to increase the throughput. So at this point in time, I want to introduce Bytewax. I mean, I already kind of have through that, but I'll just kind of get more concrete here. So if you're not familiar with Bytewax, it's an extremely extensible data processing framework at a high level. It was designed to be streaming first with a Python native interface so that you can take advantage of the whole Python ecosystem. It uses a Rust engine. It's based on top of an open source Rust processing engine called Timely Data Flow. It allows you to do all those stateful stream processing capabilities that you want, windowing, aggregations, etc. And then it's easy to scale in a cloud native capacity, so you can run it on top of Kubernetes. And there's no like vendor lock in there. And then it's also has all the niceties around that you don't want to think about, like, hey, my node crashed, I need to recover, those sort of things. One of the additional nice pieces that I think differentiates Bytewax is that it can run literally almost anywhere. There are people running it today on Kubernetes or on single nodes or on Raspberry Pis or in like edge computers on ships and in aircraft. So that's, I mean, it was cool for me to see that become real. Okay, so on with how we're going to use Bytewax as a solution to some of these difficult streaming problems, or just to make life working with streaming data easier. And to do that, I think in the proposal, it actually said I was going to do some Hacker News analysis thing. I do have something for that I can share later, but the one we're going to do right now is analyzing Wikimedia event streams, because it's readily available. It's a stream, and it's easy to do some fairly interesting stuff with it. So if you're not familiar with Wikimedia's event stream, I'll just quickly show you what it is. So they have different parts of the API. One of those is like the recent changes. So these are people editing all the different Wikimedia assets. And so you can see these fill up pretty good. It's not like anything crazy, but yeah, there's enough real-time data here for us to do something interesting. So we're going to make a streaming workload to understand what's happening on the Wikimedia recent events change log. So this is what we call, with Bytewax, we call this a data flow. A nice way to describe any data processing, whether it be batch or streaming, is through a graph. You've probably heard DAGs before, directed acyclic graphs. So it's a nice way to visualize and understand where you have a node for sort of each capability or transformation that you're doing. So in this case, we have a input node where we're actually streaming those HTTP stream events. And then we'll have a processing node where we do some deserialization, and then we're going to reformat the data so that we can use it in a window. And then we're going to accumulate our data in a window, and then we can understand it. We kind of simplified this example where we're just going to print it out from our output node, which is just a standard output. But you would, in a production system, you would move your data somewhere else where it can be retrieved by some other part of the application, or even just stored for later usage. All right, so now we're going to jump into writing some code, and then we can, or looking at some code, I guess, and then we can run this workflow. Unfortunate thing about sharing your whole screen is I can't actually see if there are questions or if I'm running out of time, but I think I'm still good here. So like I mentioned, stream processors provide semantics to describe how to connect the data sources, do some processing, and then how to write out to different sinks. So in Bytewax, there's an API for writing input, and there's also built-in input connectors. So you can connect to Kafka, WebSockets, HTTP streams. You can even connect to non-streaming things if you wanted to use it in a batch manner. But for this use case, we're going to connect to an SSE stream, which is the Wikimedia stream, and we're going to write a custom connector to do that. Or we're going to look at the code to write a custom connector to do that. So you should all see my VS Code over here. Bytewax data flows for writing Bytewax data flows for stream processing is just like writing regular Python code, which is kind of nice. You do have to know some of the nuances of the API when you get into doing more advanced things like using the custom input and output connectors. The reason being is that the Bytewax processing engine is meant to allow you to do distributed processing, and so you need to have at least provide the ability for users to write input connectors that allow you to process partitions of data, so that you can actually speed up your throughput. You can imagine in some systems you have the data is already partitioned. So in Kafka, for example, the data is partitioned by keys or something like that. So when you write a connector to achieve the highest throughput, you want to be able to have a separate worker for each one of those partitions so that you can maximize how much data you're processing. Okay, so that's like a total divergence. But so we've written a Wikimedia input connector here. What will happen in Bytewax is we're going to create a data flow object, and then we're going to use the input operator, which is a class method of the data flow. We're going to assign it this wiki source that we created up here. So behind the scenes, what Bytewax does is going to say, okay, what are the parts of this source? So what are the partitions? In this case, there's just one because it's an HTTP event stream. We can't have multiple partitions there. And then it's going to say, okay, cool. Now I want you to build the partition. So each worker will build its partition. We only have one in this case, but it's going to build that partition, which in turn returns this wiki partition. And the wiki partition is the actual code that describes how we're going to iterate through. So if you remember the generator, this is kind of like working like a generator. So this partition thing is going to have some handle into the stream, And then it's going to have this functionality that says, get me the next batch of data. Whether that's 1 or whether that's 1,000, you can actually tune that. In this case, we're using an async library within this. So Bytewax is synchronous, but many libraries in Python are asynchronous. So this is a way to deal with the asynchronous library. So we're basically using a workaround to kind of batch up the asynchronous generator up here. And the generator itself is where we actually attach to Wikimedia's recent change. Okay, so that's like the hardest part. This is like, it's like starting on advanced. That's like the hardest part about Bytewax is making your own custom input. If we were just using Kafka, all we would do we would just write one line down here that just said like Kafka source and then my topic name. And that would be all we need to do. All right, so next up, I have to apologize. I can't see the chat or any of the questions, so I will work on those at the end. Hopefully I leave enough time because I can't answer them as we go. So the next part we want to do here is we want to take this data from Wikimedia. Oftentimes we're going to have to deserialize or parse that, and then we're going to prep that data to be used in the next steps. And when I say prep that data, it was what I mentioned before, that we need to get it in the right format for our window where we have the user key as the first part of our tuple, but I'll talk about that in a second. So we're going to use simple operators, and you'll see them in the data flow. We go back to the code. So map is like a one-to-one transformation. The way this works in Bytewax is you use the map operator and you pass it a function. And basically for every piece of data coming through, you're going to run that function. So every time we get a new event from Wikistream, the Wikimedia will use JSON loads to turn it from a JSON to a dictionary, and then we're going to key on user. So the reason we're going to key on user here, what we're doing is we're going to look at how many events a user does in a time window. And so in order to do that, we need to be able to group the events by the user. So that's why we pull out that user key. Okay, so the next step, now that we have our data formatted correctly, is the fold window, and then we're going to do our little like calculation and post-processing. Window operators or batch operators or join operators, they are the kind of more advanced capabilities that are the reason why stream processors exist. Keep things in order to make it easier to reduce things over time, and have simple semantics to describe different types of streams. So this is what a window looks like in Bytewax. So there are a couple of important things we need to call out. One is that we need to know how to parse the time. So there is a functionality to provide a time function, and that's passed into the fold window. So in our flow, we're adding a new operator, another node in the graph, and that's the fold window operator, and it's given a name. And the reason for the name has to do with state and state recovery, which we're going to skip for now. It's given an event clock config, or it's given a clock configuration, so that can either be system or event time. It's given the function that you're going to use for how to get the event time, and then it tells you this little thing here. It tells you how long to wait for late arriving data, which I set as arbitrarily at 2 seconds. The next thing we need to define is the type of window. So there are a few different types of windows, one of which is a tumbling window, which is just sort of like discrete time chunks and what happens in between those. Next, in the tumbling window, we need to tell Bytewax what is the object that we're going to accumulate things in this fold window operator, because we're not reducing yet. And then we need to tell Bytewax what's the actual functionality we want to use to accumulate. So we're saying, hey, we want everything in this window of time to be in a list, and we want to use this function to build that list. And in that function, we're just appending to the list, and we're saying we want the title and the timestamp. And then the final calculation, which is super simple that we're going to do, and the final formatting. And then we're going to wrap this up so we have at least a minute or two for Q&A, is that we're going to run another map with a lambda function. In that lambda function, we're pulling out the length, which is just the count of how many changes they made, and then the username. So let's run this thing. So to run it, this is one other nice thing, and this is part of the reason we designed Bytewax this way, is you can just run Bytewax locally in process like you're running like a Flask app or something like that. So we'll using the Bytewax run module, we're going to run our data flow and run the flow. Oops, wait, maybe I'm not in the right. Oh, no, I misspelled. Sorry. Cool. So this should start churning out things after 5 seconds has gone by. Well, let's make this way bigger. So we can see what's going on. So the next thing we could do here that would be fun is we can like look at the bots. I'm going to stop this in a second. So we can go back and we can look at, what human is modifying 12 pages. It looks like it's a bot. So you can tell when there are bots, and maybe you could determine if there were malicious bots in some way, shape, or form. Okay, so wrapping this all up. That's it. Thank you for listening. I'm going to turn back and look at things. If you want to go to Bytewax and give us a star, that would be really appreciated. Okay, here we go. Questions. Patrick asked, is it possible to replay the stream, or is the processing stateless? This depends on where the stream comes from. If the stream itself is replayable, yes. So Bytewax will handle persisting state. It will handle tracking progress. So if you're using Kafka, you can recover from the right offset, and you'll recover with the right state. Marcus answered. Let's see if we can get another one. Another question. Link to GitHub. Is it an overall PyData GitHub? I think you all can see the resources, and I'll post that as well in the Discord. In the resources tab, I don't know what your exact screen looks like. There's a link to the GitHub repo. It is Bytewax/Bytewax. It is not part of PyData. No, it is not in the overall PyData GitHub. No, it's not in PyData GitHub. It's a separate company and project. That looks like all the questions I had. Cool. And I think we're over time here, or we're just at time. So I think we're good. Yeah, I think you all will be going to your next session now. Thank you so much for coming. Yeah, see you all later.